Hi, I'm Dana, and this is my power supply.
It will cover electrical engineering achievement requirements for the analog circuits for levels 1, 2, and 3.
Here's a diode bridge to rectify the signal that goes into the voltage regulators.
Here's a close-up of the physical circuit that I built. Here's the wiring diagram for it. Right here is the bridge rectifier that uses diodes. It takes the AC signal and filters it, making the positive side of the wave go this way and the negative side go this way. And these capacitors right here filter it, help to smooth out the bumps into a DC signal. And this is an indicator diode for the rectifier being active.
As you can see here, it is giving out 8.4 volts from these power regulators here, these voltage regulators. They're using these BJTs and a feedback loop in order to regulate the voltage and to limit the current.
Here's a picture of the voltage regulators. The voltage regulator uses BJTs, obviously, in the circuit, and feedback loops. One of the feedback loops to regulate the voltage comes through here, where the current comes down here into the base of this Darlington pair and tries to drive the output voltage high. But as the voltage increases over here, this node also in this voltage divider increases. That in turn makes this BJT siphon off the base current from the Darlington pair, which brings the voltage low. This balancing act that this BJT does makes the regulated voltage. Also, there's a feedback loop through here for the current limiting, where as the current flows through here, it creates a potential difference across this resistor. When that reaches a certain point, this BJT right here turns on, which siphons off base current from the Darlington pair. This feedback is also a balancing act similar to the voltage regulating one.
So here is the temperature control circuit. Here is the op amp that goes into the MOSFET right here. And over here's the thermistor, which will help turn on the fan, and there it goes.
Here's a close-up of the circuit. And here is the wiring diagram for it. Here we see the op amp, and here the thermistor, which is the main control for this. When the thermistor is cold, it has a high resistance which drives this voltage high on the negative end, which in turn drives the output from the op amp down to ground, which makes this BJT off, making the fan also off. When the thermistor heats up, its resistance goes down, which makes this voltage right here come down. When it crosses V fix, this fixed voltage, the op amp will turn on, which will cause this MOSFET to saturate, making this voltage right here approach 17 volts. And that turns the fan on. So you can see how this circuit uses the MOSFETs and the op amp, and is also a temperature control circuit.